time ready? Okay. What I did for John. Okay guys, so now we're going to cover antenna alignment. Yes, I'm going to do it again. It's not kidding. But antenna alignment. This is one of the #1 installation frustrations that we have in the microwave business. Okay? So we're going to cover antenna alignment briefly. Again, this is the most frustrating thing for any installer. And you guys are not going to let me lie, okay? This is the one thing that takes more time than anything when you're doing microwave backwards. We already covered the actual configuration, we covered the management. Now, when you're in the field aligning this, there's a couple of tricks to do it. First, high performance antennas have very long noise or side lobes. Remember, you're shooting with a 1 to 3 degree beam. So any slight movement you make is going to affect the actual alignment process. Very small adjustments are needed for azimuth and elevation. When is my alignment finished? When can I say I'm done? I can go home when I'm within 3 plus or minus dBs of my expected target RSSI. So when you get the PCN and you get the triangle configuration report, you're going to get expected target RSSI. If that is -50, you got to be within 3 dBs up or down of that mark. Antenna alignment overview. When we align the antennas, what do we do first? Make sure ATPC is off. The reason why is because if ATPC enabled, what happens? If I go the opposite way, what's going to happen is ATPC said, well, my link is actually going under pressure, it's going low modulation. I'm going to kick up the power, and it's going to start actually correcting for that. So you don't want that. So make sure ATPC is off. Align the antennas. The only certified triangle way to align an antenna is using the actual cable, RSSI cable to BNC. Now this cable is sold by Triangle, and it is rubberized, so it's really good build quality. Now this cable is going to be connected right next to the BNC on the ODU. Once we do this, here we go. We're going to connect it to the ODU, and then we're going to plug it into our voltmeter. We're going to have it on DC voltage. There's going to be a table on the manual for each product, going from 0 volts to 4 volts. There's going to be a correlation between voltage and RSSI. The higher the voltage, the better RSSI. Now, what do we need to align the antenna? A GPS is always good, a compass for rough alignment, and a mirror. What do you want a mirror for? When you go far enough out from a point-to-point link, you will probably not going to see your far side. So you want something to reflect light, flash to the other team. When you do this, and I'm not saying a little pocket mirror, not a lipstick mirror, no, a real mirror, a hand-sized mirror at least. So you can go ahead and flash your teammates, and you can see, oh, this is where I am. So they can rough align and say, okay, he's that way, I'm going to turn the antenna this way. Okay? Cell phone. Cell phone's always good, it's a must. Do not run out of battery, just full charge. Camera to document the line of sight records. Especially in urban environments, you may put up a link and you don't know if a month later or a year later, a building comes up in the way or a bridge or something comes in there. Urban environments, rural environments, foliage, a tree grows in front of it, or natural just starts getting more foliage on the tree, you will have impact on the RSSI. That information provided by the coordinator of the FCC. You can also use your Triangle config report to do this. Best practice to have 2 teams, 1 each end. If you don't do this, it's a little more difficult and dangerous as well. You can get from Triangle a test configuration report. Here we highlighted the actual transmit power must be the same on both sides. RX signal. So what are you expecting for your target RSSI? Here we actually have a -44. When you align the antenna, you do not want to have -55, -56, -50. You want to get within 3 dBs of that actually -44. Then the thing is, if you outsource tower work, Do not sign off on the actual alignment until you are sure that it's within 3 dBs plus or minus of the expected target RSSI. Alignment process. First is the coarse alignment. The coarse alignment is getting the actual azimuth left to right